Have you ever sat in a quiet room when a single ray of sunlight sneaks through the blinds and suddenly you notice countless tiny specks drifting lazily in the beam? They float, twirl, and dance as if suspended in slow motion. At first glance, it seems like nothing more than dust. But here's the surprise. Those little specks are showing you one of the most profound secrets of physics. They are windows into a hidden world where air itself is alive with motion. The stillness you thought was around you is, in fact, a storm of invisible collisions. That lazy swirl of dust is your personal invitation to watch molecules at work. Why do these specks behave this way? Why don't they fall straight down like sand in an hourglass? Why do they seem to drift endlessly, suspended in a strange, weightless ballet? To answer, let's pull back the curtain and reveal what's really happening in that beam of light. The air around you feels calm. If you sit in a closed room, you might think nothing moves. But in reality, every cubic centimeter of air contains trillions upon trillions of molecules, nitrogen, oxygen, carbon dioxide, all rushing around at breakneck speed. Each one zips about at hundreds of meters per second, colliding, rebounding, and weaving through the invisible crowd. You can't see these collisions directly. The molecules are far too small and far too fast. But the dust specks drifting in sunlight are big enough to catch the light and small enough to be jostled by this microscopic chaos. That's why they dance. Each random bump from surrounding molecules nudges them in a new direction. This phenomenon even has a name: Brownian motion. It's not dust deciding to dance, it's dust being pushed around by an unseen ocean of moving air. Here's an analogy to make it clearer. Imagine standing in a huge crowd at a music festival. From above, the crowd looks almost like a still sea of people. But if you put a beach ball on top of that crowd, what happens? The ball doesn't stay in one spot. It bounces around, pushed one way, then another by the random motions of the people underneath. None of them are trying to move the ball, but their small, chaotic shoves add up to a jittery, unpredictable dance. That's exactly what's happening to a speck of dust in a beam of light. The beach ball is the dust particle. The people are the countless molecules of air. Each collision is tiny, but together they create that mesmerizing, drifting movement you can actually see. Now let's zoom in. If you could shrink yourself down to the scale of a dust particle, the world would look wild. Molecules of oxygen and nitrogen would slam into you from all sides, billions of times every second. Sometimes the hits would cancel out and you'd hardly move. Other times, a few extra molecules strike from the left, sending you wobbling to the right. A moment later, another cluster shoves from below and you drift upward. The path is never smooth or predictable. It's a zigzag of chance encounters, a microscopic version of being caught in a chaotic crowd. From our human perspective, it looks graceful and slow. But at the particles level, it's violent chaos, constantly reshaping its course. This is where the story gets even more fascinating. When botanist Robert Brown first observed this strange jittering of pollen grains in water under his microscope in 1827, he thought at first it might be life itself causing the motion. Were the grains alive? But then he tested dust and soot, clearly lifeless, and saw the same restless movement. It wasn't life, it was physics. The dust particles were being knocked around by molecules he couldn't see. At that time, many scientists still debated whether atoms and molecules were even real. Brownian motion became a crucial clue. Later, Albert Einstein would provide the mathematical explanation that not only described the motion, but also helped prove the very existence of atoms. So the dust floating in your room isn't just a curiosity. It's a piece of evidence in one of science's greatest revolutions, the proof that matter is made of atoms. Think about how powerful that is. Something as ordinary as dust in a sunbeam can prove the existence of an invisible world. It's like nature left us a clue, hiding in plain sight, waiting for us to notice. You don't need a particle accelerator or a giant telescope. Just a quiet room, a sunny window, and a curious eye. Suddenly, you're watching molecules in action. And every swirl of dust is a live demonstration of physics that underpins chemistry, biology, and even our understanding of life itself. But let's make the analogy even simpler. Picture a balloon filled with air. The reason the balloon holds its shape is that molecules inside are constantly colliding with its walls, pushing outward. Now imagine shrinking that balloon down until it's the size of a dust particle. The collisions inside are still happening, but now you're watching the outside molecules slam into it too. The dust isn't floating serenely in calm air, it's being battered from all directions by invisible bullets of gas. The path it takes is the story of those collisions, drawn in slow motion before your eyes. This raises a beautiful thought. When you look at dust dancing in light, You are actually watching randomness made visible. It feels like chaos, but it's not meaningless. It's the direct signature of molecules in constant motion, the heartbeat of physics at the smallest scale. And if you think about it, this random dance connects you to every level of science. The same chaotic jostling drives diffusion, mixing gases and liquids until they're uniform. It shapes how smells spread across a room, how sugar dissolves in tea, even how life itself sustains its chemistry. Dust in a beam is just the visible tip of a universal iceberg. There's also something poetic in how the sunlight reveals it. Without the beam, the dust is invisible, hidden in the air. But when light hits, it scatters off the tiny particles, making them glow. It's as if the sun is holding up a magnifying glass to show you the hidden choreography of molecules. Every flicker, every twist is a story written in light about the invisible world surrounding you. And once you've seen it, you can't unsee it. The air you breathe will never feel empty again. It's alive with motion, buzzing with collisions, and the dust is your translator, turning that invisible activity into a visible performance. Here's another angle that might change how you think about it. If air molecules are moving so fast, hundreds of meters per second, why don't dust particles just rocket around like bullets? The reason is balance. Yes, molecules are incredibly fast, but there are so many of them and they hit from all directions. The overall effect is a gentle random drift, not a violent launch. It's like being in the middle of a crowd where punches are flying everywhere, but because they come from all sides equally, you just wobble back and forth instead of being thrown across the room. What looks slow and graceful is actually the product of furious activity too small for our eyes to see. So the next time you see dust swirling in a sunbeam, pause for a moment. Realize that you're not just watching something mundane, you're peeking into a microscopic universe. Those lazy specks are testifying to the restless nature of matter itself. They are evidence of a hidden storm that never stops, of molecules dancing a frantic waltz that fills every cubic inch of air around you. And through them, you are connected to the history of science, to the discovery of atoms, and to the beauty of physics in its purest, most elegant form. But the story of dust doesn't stop with proving atoms. Brownian motion has become one of the most powerful concepts in science because it teaches us how randomness itself can be meaningful. At first glance, the jiggling of dust looks chaotic without pattern or purpose. Yet underneath that chaos lies a statistical order. Each step of a particle may be unpredictable, but if you watch many particles for long enough, patterns emerge. They spread out in a way that can be described by precise equations. Equations that explain how perfume drifts across a room, how smoke curls through the air, and even how nutrients move through the cells of your body. In other words, the same dance that makes dust shimmer in sunlight also drives life itself at the microscopic scale. Let's use another simple analogy. Imagine tossing coins over and over again. Each individual toss is unpredictable. Heads or tails, you can't know for sure. But if you toss 1,000 coins, you can be certain about the overall pattern. About half will be heads, half tails. Brownian motion works the same way. Each collision that nudges a dust particle is random, but the big picture, the way particles spread out over time, follows reliable rules. That's why scientists can take something that looks like chaos and turn it into equations that predict behavior across physics, chemistry, and biology. Dust in sunlight isn't just random wandering, it's statistics written in the air. And here's where the eureka moment really hits. When Einstein analyzed Brownian motion in 1905, he gave the world not just proof of atoms, but also a method to measure their size. By studying how pollen or dust moved under the microscope, he could calculate the scale of the invisible molecules bumping into them. Suddenly, what seemed intangible became measurable. Dust in sunlight turned into a ruler for the microscopic world. It was one of the final pieces of evidence that convinced the scientific community that atoms weren't just abstract ideas. They were real, physical entities shaping everything. Imagine that. Every time you notice a speck drifting in a sunbeam, you're looking at the exact kind of evidence that once changed the course of science forever. But dust carries even more meaning. It reveals that the air we live in is never still. Even in the calmest room, even on the stillest day, the molecules around us are always in motion, colliding, bouncing, spreading. The gentle sway of dust shows us that we live inside a sea of restless energy. Without this constant motion, life as we know it wouldn't exist. Cells rely on diffusion, the spreading of molecules driven by Brownian motion, to transport oxygen, glucose, and countless other molecules they need to survive. If molecules didn't wander randomly, your body wouldn't be able to function. That patch of sunlight on your wall is more than decoration. It's a glimpse into the engine that powers life. And there's a poetic side to this too. Think about how dust appears only when light reveals it. Without the sunbeam, the particles are invisible, and we forget they're even there. But once illuminated, they remind us of the hidden layers of reality. It's as if the universe is saying, "Look closer, there is more than you think." Those lazy spirals are the signature of collisions happening at a furious pace all around you. What feels like calm silence is actually a microscopic storm, and dust is the messenger that makes it visible. Now let's connect this back to the bigger picture. Brownian motion isn't just about dust or pollen. It shows up in stock markets, where the unpredictable jostling of prices resembles the random walk of particles. It shapes the spread of rumors in a crowd, the growth of bacteria on a plate, the way galaxies form clusters in the universe. The same mathematics that describe a speck of dust can describe some of the largest and most complex systems we know. That's the magic of it. The small reflects the vast, and the everyday reveals the cosmic. A dust mote in your living room is connected to the deepest laws of order and randomness in the universe. So the next time you sit in a quiet room and sunlight catches the air, don't dismiss those drifting specks as nothing. Watch them closely. See how they twist, hover, and drift with no clear direction. Realize that you're watching molecules you can't see collide and shove, their energy transferred into motion you can see. What seems like a simple dance of dust is actually the choreography of atoms, the proof of invisible worlds, the same lesson that once convinced humanity of the reality of atoms themselves. And here's the real takeaway. Dust in a sunbeam is more than just physics. It's perspective. It reminds us that even in the most ordinary moments, there are extraordinary truths hidden in plain sight. It teaches us that randomness is not emptiness, but a form of order waiting to be understood. And it shows that with nothing more than light, air, and a curious mind, you can glimpse the invisible architecture of reality itself. So next time you notice dust floating in sunlight, pause. Let it sink in that you're not just watching dirt. You're watching history, physics, and life itself in action. That fragile dance is the universe whispering one of its deepest secrets. Everything is in motion. Nothing is truly still. And once you see that, you'll never look at a sunbeam the same way again. If this journey through the hidden dance of dust sparked your sense of wonder, imagine how many other everyday miracles are waiting to be decoded. That's exactly what we do here on How It Actually Works. We turn the ordinary into a key for unlocking the extraordinary. So hit like, share this video with someone who has stared into a sunbeam, and subscribe for more. Together, we'll keep finding the hidden laws of the universe, hiding in plain sight, waiting for us to notice.